Alright, so I'm back to using the thick marker, and I moved on to 9.36 because the first few problems in the mass spectrometry problem set in the back of the book seem to deal with more complicated problems that I have to work out. There were certain things we skipped in class, but so moving on to 9.36. 9.36. So basically, let me just move my screen. So it says, predict the masses and relative intensities of the peaks in the molecular ion region of the following compound. So here's the molecule that they give us. It's benzene ring, right, with a bromine attached and a chlorine attached. Okay, so the book says, first calculate expected mass of the compound shown for C6H4 plus 79 bromine plus 35 chlorine. So those are not the, right, so they say this is C6H4 plus 79 Br plus 35 Cl. And they're, okay, so they say these are the it's not an ion, whatever it's called when it has more neutrons than it's supposed to. I forget what that's called. So they are saying that the mass to charge ratio of this entire molecule when you get rid of an electron should be 190. And then they say you have to, so what's going on, we need to find a couple different masses because we're dealing with whatever it's called when I'm trying. Wait, let me just look up that word real quick. Isotope. Okay, we're dealing with isotopes, so we need to find the different isotope masses. So this would be the mass with isotope bromine 79 and chlorine 35. So now they say, what is the isotope when you have, what is the M to Z? So what's MZ when you have bromine, you have chlorine 37, okay, so when we have 37 Cl, and then we have 79 bromine. So it's the same bromine, but it's the M plus 2. The M plus 2 for chlorine. Okay, so it's the M plus 2 isotope of chlorine. That would equal, obviously, it's going to equal 192 because you only went up 2 neutrons. And then for, obviously, the other isotope, so let's say that we have Cl35, we have Br81. Okay, this is the M plus 2 isotope for bromine that we're dealing with. Obviously, the MZ is also going to be 192. Right? And then, the last one is when they're both the isotopes, right? So if we have chlorine 37 and we have bromine 81, this is 81, this is M plus 2, this is M plus 2, which is 4, so obviously M over Z is going to equal 194. Alright, so then now that we got these, which I'll scan and put up in the Facebook page, it says the relative ratio of 79 Br and 81 Br is 1 to 1, right? So 79 Br to 81 Br is 1 to 1. For the two isotopes of chlorine, 35 and 37, Cl35 to Cl37, they're saying that equals 3 to 1, right? So it says, therefore, if you have one bromine and one chlorine in the molecule, we must simplify the expression of 3 to 1 and 1 to 1 equals 3 to 4 to 1. Okay, so they're saying you have one bromine and one chlorine. So here we have a 1 to 1 ratio for bromine and a 3 to 1 ratio for chlorine. So you need to simplify the expression. Here they show this expression, 3 to 1 and 1 to 1. And they say that equals 3 to 4 to 1. Now, I don't exactly understand how they're getting this. I think it has something to do with probability, and I'm going to have to look that up, or if someone could look it up, it would be really helpful. But I think I've been noticing that when you multiply these, you get this. When you add these, you get this. And when you multiply these, you get this. But let's see what happens in other problems. Okay, so 3 to 4 to 1. So, okay, they said, so the ratio of the peaks will be, so we have Mz equals 190, which is this molecule with the two lighter isotopes of bromine and chlorine, right? The chlorine 35 and bromine 80, bromine 79. So since it's 3 to 4 to 1, they say that this is going to make up 7. Let's see what they said. 190 is going to be. This makes, I don't know. This is what they say. The ratios of the peaks for MZ 190, the M plus 2, which is 192, and the M plus 4, which is 194, they say it's going to be 100% to 77% to 24%, right? Now, what? How did they get that? The ratio. I don't know. Maybe I'll have to make another video and figure that out and come back to it. I'm sorry if these things are sloppy, and maybe it would just be better if I try going over what we read. Maybe I don't understand it enough to actually start this yet, but let's see. So this will be up in the Facebook page later and need help. So thanks. Bye.